Welcome to 10x Roadmap to Ready to Master Retrieval-Augmented Generation. Let's dive in and 10x your knowledge of RAG's roadmap.
RAG stands for Retrieval-Augmented Generation. This is a key concept in large language models. RAG is used to improve the accuracy of large language models, or LLMs, by providing them with relevant context. This accuracy is achieved by connecting the LLM to some external data source. Traditionally, an LLM depends on pre-trained data for its responses. It receives a query, generates a response using its training data, and provides the completion. Without RAG, the LLM has no exposure to external documents or proprietary data, limiting its knowledge to what it was trained on. RAG helps by providing context to the LLM. It does this by connecting the LLM to external data sources. The context provided is a specific, relevant subset of data tailored to the user's query. As shown in this diagram, the query is passed to an external data source to retrieve the necessary context, which is then added to the query for the LLM. A vector database is the component used in RAG to store this external knowledge. A vector database stores vector embeddings, which are numerical representations of unstructured data like text, images, or audio. Vector embeddings numerically represent unstructured data such as text and images. This representation allows for similarity-based search. This is different from traditional database systems, which are designed to perform exact matching. With similarity search, you can look for beautiful and get pretty as a result, because their vector embeddings are placed close to each other in the database. Now, let's explore how a vector database stores documents. Documents are converted into vector embeddings, chunked, and then indexed. Embedding is a numerical representation of data. Chunking breaks down large documents into smaller, manageable, semantically meaningful pieces. Indexing means to organize chunks so as to make similarity searches across massive datasets fast and efficient. RAG in action begins when a query is passed to the vector database to retrieve the relevant context. In the next step, this context, along with the original query, is passed to the LLM to generate more accurate results. The complete RAG process involves 5 steps. The query is passed to the vector database, the context is augmented to the query, the context is returned, and the LLM generates a completion. One key advantage of RAG is providing real-time intelligence to LLMs by acting as an external memory bank for relevant data. Another benefit is reduced hallucinations. RAG grounds the LLM in verified external data, improving factual accuracy. RAG also minimizes token usage by extracting and providing only the relevant data to the LLMs, instead of the entire document. Thank you for watching this video. Let's build the future together.